Hi students and friends, welcome to the channel Learn and Teach by Sir AYAZ. This is your host and teacher Syed Ayazuddin Haider. So I'm solving the paper for 9701, that is A levels chemistry. This time I've selected paper 22. It's of February-March 2023. The total time for this paper is 1 hour 15 minutes. You have to answer all the questions. Total marks for this paper is 60. These are some resources which are provided in this paper, that is important values, constants and standards, as well as the periodic table of elements. So let's continue with the paper. Here's question number 1. The following electronegativity values of elements can be used to predict the chemical properties of compounds. Use the information in table 1.1 to answer the following questions. Here's table 1.1. Element provided is hydrogen, lithium, carbon, oxygen, sulfur. Pauling electronegativity value, first ionization energy and second ionization energy in kilojoule per mole is provided here. Part A, number 1, define electronegativity. You know it's the power of an atom to attract electrons to itself. So you write power of an atom to attract electrons to itself. Remember, they are attracting electron toward itself. And those elements which have this power, they are known as electronegative elements. Non-metals are more electronegative when comparing with metals. Number 2, O and S are in group 16. Explain the difference in the Pauling electronegativity values of O and S. See the O and S, where is O? Here is O, group 16, here is S, this is group 16. If you see the Pauling electronegativity value, oxygen have 3.5 and sulfur have 2.6, which is lower than of oxygen, which means oxygen is more electronegative than sulfur. Now, if you look at the position of oxygen and sulfur, oxygen is in the second period. These are the periods. Periods: first, second, third, fourth, fifth. Oxygen is in second period. Sulfur is in third period. So oxygen must be having fewer shells as compared to sulfur, which means there will be less shielding of incoming electron or outer electrons. Oxygen also have lower nuclear charge than sulfur. That's why it has greater attraction for the incoming electrons by the nucleus. The main reason is it has fewer shell and there will be less shielding of outer electrons. So what we will write here, oxygen have fewer shell than sulfur, which means there will be less shielding of outer electrons. Oxygen also have lower nuclear charge. and greater attraction for the incoming electrons. Next question, B. Part 1, LiH is an ionic compound. Draw a dot and cross diagram of LiH, include all electrons. Here is Li. It's in group 1, which means it has 1 valence electrons. Here is hydrogen. It has 1 electrons. Both have 1 electrons. Hydrogen is a non-metal, lithium is a metal, so it must be forming ionic compound. They have already mentioned here. And they are asking you to draw dot and cross diagram. So first of all, we're going to show the key. For lithium, I'm using dot for lithium. For hydrogen, I'm using cross. So lithium has 3 electrons. So it will lose 1 electron. It's a metal. It will lose 1 electron. Lithium, metal, lose 1 electron. Hydrogen, so non-metal, gain 1 electron. So I'm going to show only first shell of lithium. It's in the second period, so it will lose its valence electron from the second shell. So it will be left with only 2 electrons. So this will be the dot and cross diagram for lithium. I'm showing the inner electrons, 1, 2. For hydrogen, it will gain 1 electron. It's the electron of hydrogen. These are the electrons. This is the electron coming from lithium. So this will be the final dot and cross diagram. Number 2 suggests the shape of a molecule of H2S. Shape of molecule of H2S. We have 1 sulfur and 2 hydrogen. As there will be, look at the position of sulfur. It's in group 16, which means it has 6 valence electrons. So needing 2 electrons to complete its valence shell. So if I will show the electrons for sulfur, it will be like this. I'm using dot for sulfur. 1, 2, 3, 4, 5, 6. What about hydrogen? These are the electrons for hydrogen. So there will be more repulsion between lone pair and bond pair electrons as compared to lone pair. These are the lone pairs. These two are lone pairs. These are the bonding pair of electrons. So definitely it will have bent shape, bent or non-linear due to this. Moving to next part, C1. Write an equation that represents the first ionization energy of H. We know that the ionization energy is the amount of energy required to remove electron from the valence shell in the gaseous state of an atom. So I will write H gas. Only 1 atom, not molecule. So it must be forming plus ion, and it's also in the gas state, and 1 electron will be removed. It will be represented like this. Number 2, explain why there is no information given in table 1.1 for the second ionization energy of H. Definitely hydrogen has only 1 electron, so you can write H positive has no electron. Number 3, give the full electronic configuration of S2 plus. gas. S2 plus gas means it has lost 2 electrons. Here's sulfur, proton number 16. Proton number 16, which means electronic configuration will be like this: 1s2, 2s2, 2p6, 3s2, 3p4. Now, after losing 2 electrons, it will be left with 2 electrons in the p suborbital. So I will write for s plus 2, I will write here 1s2, 2s2, 2p6, 3s2, 3p2. D. CO2 and SO2 are acidic gases. Number 1, write an equation for the reaction of SO2 with H2O. SO2 is an acidic oxide, so it will form an acidic solution with water. It will be forming sulfurous acid. So sulfurous acid, the formula of sulfurous acid is H2SO3. Number 2, write an equation for the reaction of SO2 with NaOH. NaOH is an alkali. Alkali is a base. Base when reacts with acid. Here is an acidic oxide. It's either reacting with acidic oxide or acid. It forms a salt. So we are having alkali metal hydroxide. So definitely the other product must be water. So first of all, we need to predict the formula between the sodium and the negative ion here. So we have SO2. So it becomes SO3. SO3 will be carrying -2 charge. Sodium is in group 1, will be carrying +1 charge. Ignore the charges. These numbers will become exchanged. So we'll get Na2SO3. Na2SO3 will be one of the product. Na2SO3 plus other product is water, as I have already mentioned. The full equation must be SO2 plus NaOH gives Na2SO3 plus H2O. Let's balance the equation. I will put 2 here. It's balanced. Number 3, write, construct an equation for the reaction of CO2 with magnesium hydroxide. Carbon dioxide is a gas. When it's reacted with magnesium hydroxide, it will form a carbonate plus water. So we'll get the carbonate of magnesium. The formula for the carbonate of magnesium and carbonate. Carbonate carries -2 charge, and magnesium, where is in magnesium? Magnesium is here. It's in group 2. Group 2 carries +2 charge. So +2, same numbers, ignoring the charges. 1, 1. The subscript will be exchanged. So the final formula must be MgCO3 plus H2O. Moving to next question. E1. Complete table 1.2 by placing a tick to show which of the compounds have molecules with an overall dipole moment. So CO2, SO2, CS2, SCO. SCO must be having dipole. That's for confirm. It must be having dipole if you look at the position of these. Look at the electronegativity value. SCO. So oxygen must be the most electronegative, so there must be dipole. What about CO2? CO2 dipole must be cancelling out. There won't be any dipole here. What about SO2 and CS2? CS2. SO2 and CS2. CS2 is there's a less difference between the electronegativity value of carbon and sulfur, very less. So there isn't any dipole movement here. What about SO2? Look at the difference between SO2, that's 3.5 and 2.6. There must be dipole. The reason is that sulfur is a large, it's in the third period as compared to oxygen. And if you look at the ionization energy of sulfur comparing with oxygen, the ionization energy is very low, which means it's easier for sulfur to lose electron, and oxygen, it's very difficult to lose first electron. And look at the second value. In second, ionization energy of oxygen is much higher than second one of sulfur. So there must be dipole in case of SO2. So you write tick here. Number 2, add 150 degrees centigrade and 103 kilopascal. All of the compounds listed in table 1.2 are gases. Under these conditions, 0.284 gram of one of the compounds occupies a volume of 127 centimeter cube. Use this information to calculate the MR of the compound, hence identify the compound from those given in table 1.2. Show your working. Now we know that PV is equal to nRT. You can use this equation. PV is equal to nRT. Now from the question, what data we have? Temperature is provided, which is 150 degrees centigrade. So it will be converted to Kelvin. So you write 150 plus 273 and we'll get 423 Kelvin. What about pressure? Pressure 103 kilopascal. So we need in Pascal. So I will multiply it by 1000. So I'll get 103,000 Pascal. Volume V 127 centimeter cube. It must be in meter cube. So I will divide it by 1000. So 127 multiplied by 10 raised to the power -6. That will become meter cube. Mass is also provided. 0.284 gram. Now to find MR, we also know that number of moles is equal to mass by MR or AR. Here MR is written, so we will consider MR. So putting the value of N in the equation, that is N, number of moles. What we will get? We will get PV is equal to mass by MR multiplied by RT, or MR is equal to PV MR is equal to mass into RT by PV. Now placing the values, first of all, you need the value of R. Look at this value of R here. It's 8.31 joule per Kelvin per mole. So MR is equal to mass 0.284 multiplied by R 8.31, temperature 423 divided by pressure 103,000, volume 127 into 10 raised to the power -6. We will get 76.3. 76.3 is the MR. Now I want to identify the compound. So what I will do, I will write the formula of the compounds. If you look at the compounds here, we have CO2, SO2, CS2, and SCO. So we have CO2, SO2, CS2, SCN. Let's write there MR. For CO2, MR, it's 44. SO2, MR is 64. For CS2, MR is 76. What about SCN? It's 58. So it must be CS2. So you write CS2 here. Moving to next part. The group 2 elements Mg to Ba are all silvery white reactive metals. A1, draw a table diagram to show the bonding and structure of group 2 metals at room temperature. So the marking key suggests you have to show 2 rows with a minimum of 4 particles. Particles means cations, metal cations. But I always suggest my students that's better to show at least 3 rows of cations. So the cations must be like this. 1, 2, 3, 4. 1, 2, 3. Second row. Third row. 1, 2, 3, 4. Putting positive inside. So we have this option. You can place positive inside, or they are saying it's a cation of group 2. So if you want, you can even write X2 plus. So instead of showing plus, what we will do? X plus 2, like this. X plus 2, X plus 2, X plus 2, X plus 2. What else is left? Now all this is surrounded by little circles labeled electrons, either like this, electrons. You can show this in small circles like this. This will be the final diagram. Okay, number 2, explain why Mg has a higher electrical conductivity than Na. Now they are asking us to compare the electronegativity of Mg than Na. Look at the position of Mg and Na. Here's Mg, here's Na. Na in group 1, Mg in group 2, which means it has higher number of delocalized electrons. So you can write Mg can contain more delocalized electrons than Na. B, write an equation for the reaction of magnesium with cold water. Magnesium is a metal, and whenever these metals, they are among the top reactive metals, not highly reactive, but is one of the highly reactive, but not highly reactive. So it will definitely form hydroxide and hydrogen gas. So you'll get MgOH whole twice. That's magnesium hydroxide plus hydrogen gas, H2. Let's balance the equation. So I will place 2 here. Now it's balanced. C, identify a single reagent that can be used to distinguish separate samples of dilute MgNO3 whole twice aqueous and dilute BNO3 whole twice aqueous. Explain your answer. So you can take any soluble sulfate or hydroxide. any soluble sulfate or sulfuric acid or soluble hydroxide. So like soluble sulfate, you can take K2SO4, K2SO4 or H2SO4 or soluble hydroxide like NaOH. So barium will form insoluble precipitate, BaSO4. BaSO4 is insoluble precipitate, and with sodium hydroxide it will form barium hydroxide, BaOH whole twice is insoluble precipitate. So what about magnesium? Magnesium forms soluble one for magnesium sulfate or magnesium hydroxide. Okay, moving to next question. D1, describe what is observed when SRI2 aqueous reacts with concentrated sulfuric acid. Now, SRI2 is strontium iodide. When it's reacted with concentrated sulfuric acid, there will be number of products. Like we will be getting sulfur, we will be getting iodine, we will be getting hydrogen iodide, we will be getting H2S gas, hydrogen sulfide, and get some insoluble precipitates also. So for sulfur, what you will write, it must be produced as yellow solid. So you'll write yellow solid here, yellow solid. For iodine, what you will get? You will get purple gas or gray solid. What about hydrogen iodide? Gives a misty fume. So I will write misty fumes. What about hydrogen sulfide? Produce gives a rotten egg smell. So you write rotten egg smell. And you will also get white precipitate. Compound X and anhydrous group 2 bromide is dissolved in water and titrated against aqueous silver nitrate. A solution containing 0.250 gram of X requires 33.65 centimeter cube of 0.05 mole per dm cube AgNO3 aqueous for complete reaction. Identify X. Show your working. So first of all, we need to calculate the moles of AgNO3. Moles of AgNO3 from the data provided. So according to this data, 1000 centimeter cube of solution, 1000 centimeter cube contains 0.05 moles. Therefore, 33.65 centimeter cube contains X moles. Do the cross, what you'll get? You'll get X is equal to 0.05 multiplied by 33.65 divided by 1000. So the number of moles for AgNO3 must be 0.05 multiplied by 33.65 divided by 0.0016825 or 1.6 825 into 10 raised to power minus 3 moles. Now they are saying group 2 bromide. So group 2 bromide must be reacting with 2 moles of AgNO3. So if I write group 2 bromide must be XBr2, XBr2 reacting with AgNO3. So here we have 1 mole reacts 2 mole, Y moles, let's have Y moles of XBr2 reacts with 1.6825 into 10 to the power minus 3 moles. Do the cross, so we'll get Y is equal to 1.6825 into 10 to the power minus 3 divided by 2. So it must be 8.4125 into 10 to the power minus 4 moles of Y. Now we know that Mr is equal to mass by moles. So we have the mass, we have the moles. So what you will do? We'll divide the mass, that is 0.25 by the moles, which is 8.4125 into 10 to the power minus 4. 0.25 divided by 84125, it is 297.17. 297.176. So it's reacted with, the compound is with Br, so which is XBr2. Straight away subtract the masses of Br. So 297.176 minus, it will be 2Br. So where is Br? Here is Br. It's 79.9. So 2 multiplied by 79.9, what we will get? 79.9 multiplied by 2, 159.8. Minus 159.8, 137.376. Here's group 2. It must be barium, 137.3. So it must be barium. Question number 3. Alkenes undergo an addition reaction with a 1:1 mixture of CO and H2 to form aldehydes. Figure 3.1 shows the reaction of propene with a 1:1 mixture of CO and H2. So propene, we have product A, product B, CO and H2 is added. A1 defined addition reaction. It's a reaction in which 2 or more compounds react to form product, one product. A reaction in which 2 or more compounds react to form one product. Now for compounds, you can even write molecules. Or even reagents. Number 2, aldehydes A and B are structural isomers. State the type of structural isomerism shown by A and B. You look at the structure, A and B both have same functional group. CHO. CHO is the functional group for aldehyde. So it must be positional isomerism. Positional isomerism is the one which have same molecular formula but different position of the functional group. So you write positional isomerism. Name A. There must be 4 carbon atoms in it. 1, 2, 3, 4. And it's an aldehyde. So you write butanal. It's a butanal. Number 4. The complete reaction of propene with a 1:1 mixture of CO and H2 produces A and B. Only the product mixture contains 96% A and 4% B. Calculate the mass of A produced in this reaction when 5 × 10⁻³ kilogram of propene is used. So according to this figure, according to figure 3.1, 1 mole propene gives 1 mole of A plus 1 mole of B. So what about the molecular formula of propene? It's C3H6. The product we are getting C4H8O. No need to write the formula for other product. It also has same molecular formula. So if you calculate the MR, we need to calculate the MR of C3H6 and C4H8O, and we will express this in kilograms. So for propene, it's 42. So I will write 42 kilogram gives, what about butanol? It's 72. I will write 72 kilogram. Therefore, 5,000 kilogram gives X kilogram. So we'll do the cross. We'll get what? X is equal to 72 multiplied by 5,000 and divided by 42. multiplied by 5,000 divided by 42. 8,571. 571.58, 0.4285. 428 kg. Now what I will do, I will calculate the 96% of this, because they are saying in the question it's 96% A. They are getting 96% A. So 96% of A means we'll multiply 96 by 8571.428 divided by 100. So what we will get? The mass must be 8228. 8228.570 kg. This will be the final answer. Moving to next question. B. A and B show reactions typical of aliphatic aldehydes. Number 1, A undergoes a nucleophilic addition reaction with a mixture of HCN and KCN forming compound C. Complete the diagram to show the mechanism for this reaction. Include charges, dipoles, lone pairs of electrons, and curly arrows as appropriate. Draw the structure of the organic intermediate. So we must be getting a CN negative charge and H positive ion from HCN. So we are reacting with HCN. So it must be like this. O, C, H, C3H7. Oxygen being more electronegative will acquire partial negative charge and carbon acquire partial positive charge. Due to this, CN, cyanidine, which is electron rich, it's a nucleophile. It will attack the carbon, and this will make the shifting of lone pair of electrons of carbon towards, there's a bond between carbon and oxygen, one of the bond, move towards oxygen. Then we will get what? We will get this. CO will acquire negative charge now. This is negative charge. And we have C3H7 here, H here, and here we have Cn. So this negative charge will attract H positive ion. So in the end, we'll get this product, C. Number 2, table 3.1 shows information about 3 experiments involving B. Complete table 3.1, table 3.1. So experiment 1. What must be the reagent here? We are asking about the reagent here. Solution turned from orange to green. This observation with B. What is B? B is aldehyde. B is aldehyde. Remember, it's an aldehyde. So I will write it here. It's an aldehyde. So I'll write aldehyde. So it must be acidified potassium dichromate, that is K2Cr2O7. So you write acidified K2Cr2O7. Now what gives us silver mirror on the sides of reaction vessel? It must be called Toluene's reagent. What about Br2? There won't be any reaction, so you simply write no reaction with Br2. Moving to next part. Number 3B, C4H8O is oxidized by acidified potassium magnate 7. Complete the equation for this reaction. Use O to represent one atom of oxygen from the oxidizing agent. C4H8O plus O. So once it gets oxidized, there must be addition of one oxygen atom. It's an oxidation reaction, so you will simply write C4H8O2. Number 4, C is chiral molecule. Circle any chiral centers in the structure of C shown in figure 3.2. This figure 3.2. What is chiral molecule? Chiral, one which contains 4 different atoms or groups attached to it. So if you look at this, the carbon, it must be having 4 different groups. We have OH group, hydrogen, CN, and this one. The structure must be like this. We say chiral. So we have C3H7. C. When propene reacts with CO and an excess of H2 and alkane and a mixture of alcohols are formed. Instead, the alcohols are isomers of each other. Suggest the molecular formula of the alkane and the alcohols that are formed under these conditions. We have propene, so it must be forming propane. The alkane must be propane. What is the molecular formula of propane? So we'll get propane here. C3H8. What about the alcohol? We are getting propanol. Propanol. Formula must be C4. Sorry, C3 H8O. This must be propanol. Sorry, it's a CO here. So you can't have propanol. It must be butanol. It must be butanol. Butanol, 4 carbon atoms. Butanol. So you will get C4H10O. D, the reaction of ethene C2H4 with a 1:1 mixture of CO and H2 is shown in equation 1. Equation 1, C2H4G plus COG plus H2G. Reversible sign, CH3CH2CHOG. At atmospheric pressure, a cobalt-based catalyst is used in this reaction. Number 1, state and explain the effect of using a catalyst on this reaction. It simply increases the rate of reaction. Now, it's 2-mark question. You have to mention the description that's by providing alternative reaction pathway with lower activation energy, or EA. So you write increases the rate of reaction. By providing alternative reaction pathway with lower EA. Number 2, explain why the yield of CH3, CH2, CHOG increases when the overall pressure of the reaction mixture is increased. If you look at this equation, let's count the number of moles of gases. On the reactant side, what do you have? 1 plus 1 plus 1, which means it's 3. On the product side, it's 1. So there's a less number of moles on the product side. So definitely, due to this reason, equilibrium shifts to the product or right-hand side. Equilibrium shifts to right hand or product side. It's because of fewer number of moles or molecules or volume of gases on that side. Number 3, use the information in table 3.2 to calculate the enthalpy change delta HR of the reaction in equation 1. Equation 1, C2H4G plus COG plus H2G gives CH3CH2CHOG. Enthalpy change of formation, C2H4 is provided, CO is provided, CH3CH2CHO is also provided. We know that delta H is equal to delta H of the product side minus delta H of the reactant side. So putting the values, the product side, what do you have? We have minus 187, minus, we have minus 111 for CO, plus for C2H4, 52. So the final answer must be minus 128. So 111 must become plus here. So 111 minus 52 becomes minus 52, minus 52, minus 187 minus 128. Moving to the next question. Number 4, the reaction mixture is cooled to collect CH3, CH2, CHO as a liquid. Identify all types of van der Waals forces that are present between molecules of CH2, CH3, CH2, CHO. It must contains instantaneous dipole, induced dipole, and permanent dipole, permanent dipole. Permanent dipole is due to the presence of CHO. So you write instantaneous dipole and induced dipole and permanent dipole, permanent dipole. Question number 4. Figure 4.1 shows some reactions of compound D2-bromobutane. This is D2-bromobutane. So here's the reaction. We have reaction 1, reaction 2. We don't have reaction 3. We have reaction 4, reaction 5. A1. State the reagent and conditions used to form E in reaction 1. In reaction 1, we are getting alkene. It's an alkene. We are getting alkene from bromoalkane. So what will be the condition? We have alcoholic NaOH. So you write alcoholic NaOH. Or you can mention alcohol or ethanol plus NaOH. We heat under reflux. Number 2, draw the structure of one repeat unit of the addition polymer that forms from E. What is E? Here is E. It's alkene. It's 1, 2, 3, 4. It's butene. Butene. It's butene. Removing the double bond, having 2 CH3 in it. So it must be like this. Double bond is removed. This must be the one repeat unit for the addition polymer formed here. Next part. E also forms when F is heated strongly in the presence of an Al2O3 catalyst. Write an equation for this reaction. Here's F. Here's F. It's butane dash to all. So I will write the equation for this. This must be butane C4H10O using C4H8. Or you can even write the structure formula. So we'll have CH3, CH, we have OH on the second carbon, then we have C2H5, we have CH3, CH, double bond, CH, CH3. And definitely we will also get water as the other product in this reaction. B1, predict what is observed in reaction 2. we have bromide group and it's reacted with AgNO3 aqueous. It must be creamy white precipitate or off-white precipitate. Creamy white off-white precipitate forms. Number 2, identify the yellow precipitate and the organic ion formed in reaction 3. This is reaction 3. So the reaction 3 is alkaline I2. Yellow precipitate must be of iodo form, and organic ion, it must be propanoate. Propanoate, yes, it must be propanoate. We'll be getting iodo form or CHI3, CHI3 or iodo form. You can also call it triiodomethane. There is a structure. This one is removed and gives yellow with I2 and organic ion. So organic ion must be propanoate. So you can write CH3, CH2, CO2 minus or propanoate. C1. State the type of reaction that occurs in reaction 4. Here is reaction 4. Here is reaction 4. This is reaction 4. So when you are reacting with KCN, what you are getting CN, which means it must be substitution because CN is substituted Br. So you write substitution. Number 2, reaction 5 is similar to the reaction of LiAlH4 with carboxylic acids to form alcohols. Suggest the role of LiAlH4 in reaction 5. So it's definitely acting as a reducing agent. Here's reaction 5. Here's reaction 5. You see it's reducing CN2, 2CH2, NH2. So write reducing agent here. D1, figure 4.2 shows the infrared spectrum of one of the compounds D, E, F, G, or H. Use information from table 4.1 on page 14 to identify which of the compounds D, E, F, G, or H produces the infrared spectrum in figure 4.2. So we have on page 14 figure, we need to consider this table. So for your convenience, what I will do, I will draw the structure of compound from D till H. So D, which D is this Br. E is this. What about F? There's OH. G, there's CN. H, there is CH2 and H2. So these are the functional group we have. Peak for the, we don't have peak for the bromide. We have for alkene. Yes, we have alkene. There's a possibility. Hydroxy. And this one is nitrile. This one is amine. And must be having of alkanes. We have CH2 here. Alkene, hydroxy, nitrile, amine, alkene. So we have possibility of these. Hydroxy, CO, there's a possibility. What about alkene? Yes, there's a possibility. Nitrile, C triple bond, and yes. Alkane, yes. Amine, yes. Hydroxyl OH, yes. So see the absorptions one by one. For hydroxy, let's start for hydroxy. That is either 1040 till 1300 and 3200, 3600. 1040 till 1300. 1040 till 1300. One hundred, 200, 300. There isn't any peak. So this isn't, this is not there. What about next one? Hydroxy, 3200 till 3600. 3200. This is 200 and 600. We don't see any peak here. Any absorption there, I mean, sorry. So it's also excluded. What about alkene? 1500 till 1680. 1500, this 1500, 1680, between this area. No absorption. So it is also not there. So far, we don't have alkene, we don't have hydroxy. We are left with nitrile, amine, nitrile and amine. Let's see, amine. Amine must be 3300, 3500. 3300 till 3500. Yes. Again, no absorption. So amine is also absent. So it must be nitrile. It must be. Let's see. For nitrile, there must be 2200 and 2250. Absorption must be 2200 till 2250. 200 and 2250. This is the peak for CN. So you write absorption at 2200 till 2250, and it is of C triple bond N. Therefore, it must be G. Number 2, in the mass spectrum of D, the relative abundance of the molecular ion peak is 3.4. Predict the relative abundance of M plus 2 peak for D. Explain your answer. What is D? D is this. So it must be due to this bromide. Due to bromide. Then you will write 3.4 and relative abundance. So BR, we know that BR 79 dot BR 81, because you know that they are ratio 50, ratio 50, 50 to 50, or you can even write 1:1. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.